soldiers can learn to drive a tank, but thorough instruction is needed to make a good driver. The driver must know what his tank will do, how steep a grade it will climb, how wide a ditch it will cross. He must know how to inspect his tank for mechanical defects and how to keep it in running condition. Two types of tanks appear in this film. The light tank M3, which has a crew of 4 men, and the medium tank M3, which has a crew of 7. Some medium tanks have crews of 5 or 6 members. The light tank is armed with a 37-millimeter gun and 5 30-caliber machine guns, the right and left sponson guns, the anti-aircraft machine gun, the bow gun, and the coaxial gun. The medium tank is armed with 4 caliber 30 machine guns, 2 bow guns, a coaxial gun, and an anti-aircraft machine gun. The medium tank also carries a 37-millimeter gun and a 75-millimeter gun. Armor plate protects the tanks against rifle and machine gun fire. The weight of the light tank is 14 tons, and the weight of the medium tank, 28 tons. On roads, the light tank can travel 30 miles an hour for short stretches and 20 to 25 miles an hour for sustained periods. The slower medium tank will travel 20 to 25 miles an hour for short stretches and can sustain 15 to 20 miles an hour. In cross-country operations, the light tank will travel from 15 to 20 miles an hour, while the cross-country speed of the medium tank is from 10 to 15 miles an hour. Each has a cruising range of about 100 miles without refueling. The light tank will ford streams about 3 1/2 feet deep. The larger tank can pass through water almost 5 feet deep without flooding the motor. The light tank will cross a ditch about 6 feet wide, while the medium tank will cross a 7 or 8 foot trench. If the ground is firm, the light tank will climb a 45-degree slope. The medium tank will climb a slope slightly less steep. The smaller tank will climb vertical obstacles 1 1/2 feet high. The medium tank, 2-foot obstacles. Air-cooled, airplane-type engines power the tanks. Here is the 400-horsepower medium tank motor. A 250-horsepower diesel or gasoline engine drives the light tank. A tank driver should know how the power that drives his tank is transferred from the engine to the tracks. The engine is connected to the drive shaft by a clutch. This is disengaged or engaged by stepping on the clutch pedal or letting it up. The clutch is connected to the drive shaft, which drives the transmission. The different gears are engaged to give various speeds. Normally, the tank has 5 speeds forward and 1 in reverse. This animated diagram shows the different gear shift positions. Reverse and first, a powerful pulling gear, are normally locked off from the others. Pressing the button on top of the gear shift lever permits the lever to enter either of these positions for shifting. For normal starting and driving, however, only gears 2, 3, 4, and 5 are used. The transmission contains and drives the controlled differential. This device has two brakes, which are operated by pulling back the steering levers. This permits steering by slowing down either the right or the left track. When one track is slowed down by the brake, the other track is automatically speeded up. Two shafts connect the control differential to the final drive gears. These, in turn, are connected to the drive sprockets. The drive sprockets engage with the tracks and propel the tank. The tank commander and crew perform certain duties each time the tank is to be operated. A gasoline engine, which has been idle for 30 minutes or more, must be turned over by hand to remove any oil or water that has collected in the cylinders. A diesel engine is always turned over by hand before starting. The driver, meanwhile, oils the clutch release bearings. He checks the fuel tanks to see that they are full. The tank commander carefully looks over the outside of the tank, paying special attention to the track. When the tank has the oil filler pipe in the engine compartment, the tank commander checks for the proper amount of crankcase oil with the bayonet gauge. On entering the tank, the driver checks the voltmeter to see that it reads 0. He then closes the battery switch, opens the shutoff valve for the right fuel tank, and checks the transmission oil gauge for the correct amount of oil. After taking his seat, the driver makes sure the gear shift is in neutral position. He checks to see that the steering levers, the clutch pedal, and the accelerator pedal operate properly. The clutch pedal should have about ½ an inch free travel. The accelerator pedal is pushed down slowly to prevent causing a fire by forcing excess fuel into the air horn. Again, he checks the voltmeter after closing the battery switch to see that it reads 12 or more volts. He primes the engine with extra gasoline. The driver pulls out the hand throttle a short distance and is ready to start the engine. While starting the engine, the driver pushes in the clutch, closes the starter switch, and turns the magneto switch to the extreme left position. After the engine starts, the clutch pedal is released. The driver regulates the engine speed by the hand throttle to about 1,000 RPM. He then checks the instruments. The ammeter should not show discharge. The voltmeter should read between 12 and 15 volts, and it is especially important that the oil pressure be 65 to 95 pounds. The driver tests the engine ignition by running on each magneto separately. He checks the circulation of the transmission oil by opening the oil petcock on the transmission. Normally, the engine oil temperature must be at least 80 degrees before the tank can be operated at full throttle. When the engine is warmed up, the driver moves the tank slowly forward, and the tank commander inspects the tracks for loose, missing, or worn wedges and wedge nuts. The tank commander and driver make entries covering their inspection on the tank commander's report. The diesel is started in much the same way as the gasoline engine. The diesel engine must be turned over at least 4 revolutions before starting. Following that, the The checking of the instruments and the rest of the tank is just the same as for the gasoline engine. The driver oils the clutch release bearings. He checks the fuel tank. He closes the battery switch, checks the oil in the transmission, and tests the gear shift and steering levers. But the actual starting of the diesel is different from starting a gasoline engine. A cartridge starter is used with the diesel. It is very important that the breech be completely closed after the starting cartridge has been inserted. The idle adjustment lever is pulled all the way out, and the foot accelerator pushed all the way in. As with the gasoline engine, the gear shift has to be in neutral, and the clutch must be disengaged. When all this has been done, the starter switch explodes the cartridge, thus starting the engine. When the engine starts, the driver sets the idle adjustment lever to properly warm up the engine at about 1,000 RPM. He checks the instruments and circulation of transmission oil. Both medium and light tanks are driven in much the same way. To demonstrate the successive steps of tank driving, a skilled driver will operate this light tank. The accelerator pedal opens and closes the throttle, controlling the speed and power of the engine. Correct use of the accelerator, especially when shifting, is essential to good tank driving. To move the tank forward, the clutch pedal is depressed, and the gear shift lever moved to the first or second gear. Both light and medium tanks are usually started in second gear. The engine is speeded up to about 1,400 RPM. The clutch is gradually released. As the clutch engages, the accelerator is depressed to maintain the engine speed. The engine speed should not be allowed to drop below 1,200 RPM or to exceed 1,800. As the tank gains momentum, the driver shifts from second speed to third by depressing the clutch pedal. He moves the gear shift lever to neutral, then to third, and engages the clutch. When approaching an obstacle or steep grade such as this, the driver may shift from a higher gear to a lower one by double clutching the shift. Here the driver demonstrates double clutching in simulated slow motion. He depresses the clutch pedal part way, shifts into neutral, and releases the clutch pedal. The engine is then accelerated to increase the speed of the drive shaft so that the speeds of the engaging gears will be approximately the same. The clutch is disengaged again, and the shift is quickly made to the lower gear. In steering the tank, levers are used. To steer to the left lever is pulled back, and the accelerator depressed to maintain the speed. This causes the left track to slow down and the right to speed up, thus turning the tank. To prevent throwing a track, very sharp turns are not made. Turns should be anticipated by slowing down the tank, then applying power to the tracks as the turn is made. The driving of the tank is directed by the tank commander. When outside the tank, he directs by arm and hand signals. To have the engine started, the tank commander simulates cranking an engine. After the engine has warmed up, the tank commander tells the driver to use first or low gear by holding up one finger and gives the signal to move forward. To have the driver change direction, the tank commander signals right or left turn, The driver continues to turn as long as the signal is given. The commander signals halt in this manner. When the tank commander signals move in reverse, the driver backs the tank until halted. The commander crosses his arms in front of his head to have the engine cut off. At a distance, the tank commander controls his vehicle by using a different set of signals. To signal move forward, the commander lowers his arm in the desired direction of movement. When he wants the tank to change direction, he swings his extended arm across his body and points in the new direction. To stop the tank, the usual signal for halt is given. Inside the tank, a system of touch signals is used. To move forward, the commander taps on the driver's back between the shoulder blades. The same signal repeated faster will tell the driver to increase the speed of the tank. Pushing on the driver's left shoulder means turn to the left. To stop, keep pressing steadily between the driver's shoulder blades until the tank is halted. To back up, tap repeatedly on the back of the driver's head or helmet. To stop the tank, the clutch pedal is depressed and both steering levers are pulled back. Sudden stop should be avoided. If the tank is to remain stopped, it may be necessary to apply on the medium tank the parking brake, located by the driver's seat. To hold the light tank on a slope, the steering levers are pulled back and locked by turning the knobs on top of the levers 1/2 a turn. Before stopping the engine, if it is a gasoline engine, the driver again tests each magneto. Then, whether it is a diesel or gasoline engine, he idles it at a slow speed of about 400 revolutions per minute. The gasoline engine for 3 to 5 minutes, the diesel engine for 10 minutes. This cools the engine. The engine is then turned off, either by turning the magneto switch to the off position if a gasoline engine, or pushing the idle adjustment lever all the way in if a diesel. Then the battery switch is opened and the gasoline valve closed if the engine is not to be run for a time. To prevent airlocks, diesel fuel valves are left open. Aside from routine inspection, there are also duties of first echelon maintenance. In this, the crew keeps the tank in good running condition under the supervision of the tank commander. This includes tightening nuts and bolts, cleaning the machinery, care of the battery, tank tools, and guns. The tank crew also works under the supervision of the second echelon maintenance personnel. Here, the crew removes armor plate, changes oil, greases certain parts, and performs track maintenance operations. Oral and written examinations are generally included in tank driving instruction. And at the completion of the basic part of the tank driving course, the student must pass a practical examination in driving before taking up the more advanced work.